Well, let's talk about our other equation over here. I had to make myself a little bit of room. But what I'm going to do is I want to take this equation right here, and again, my aim is to somehow rewrite this equation, e raised to the 2x minus 5e to the x plus 6 equals 0, into a form where I get a simple exponential type of expression that I can solve by isolating the x relatively easily. Well, I can't really do that here, right? E to the 2x, that exponent is way different than e to the x. I have to do something else. Now, it may or may not strike you that this is a very familiar sort of arrangement. If it doesn't strike you, recall that we have this property with exponents that says a raised to the m raised to the nth power is really the same thing as the product of those exponents a to the m times n. Right, so what do? Well, let's factor, right? We can treat this as e to the x squared as our first term, minus 5 times e to the x plus 6. And suddenly this looks pretty familiar, right? This is a quadratic form equation. And so I can factor this as two binomial factors. And what are those factors? Well, e to the x times e to the x would be our first term, because e to the x times e to the x is e to the x squared, which is e to the 2x. We need to find factors of our constant 6, whose sum is negative 5. Well, that has to be negative 3 and negative 2. And so in that factored form, we can rewrite this and say, well, then let's take e to the x minus 3 and set it equal to 0, because if that's true, this equation is true. And we could take e to the x minus 2 and set it equal to 0 and solve for x. In the first case, we've got e to the x equals negative 3, so e to the x could be set equal to 3, and then we need to isolate x. And this is where we're going to take advantage of our logarithm rule. If I were to take the logarithm base e, which is to say natural log of e to the x, and set it equal to the natural log of 3, the natural log and the e to the x will cancel each other out, and we'll get x, and x will have to equal the natural log of 3, and that's one of our exact form solutions right here. Similarly, if I have e to the x minus 2 is equal to 0, I can say that means e to the x is equal to 2. And taking my natural log on both sides of the quantity e to the x on the left and the natural log of 2 on the right, my inverse property tells me that x must equal the natural log of 2 in order to make that equation true. And so this is the answer we were looking for.